Welcome all. In this lecture, we are going to solve one more question on the Routh stability criteria. So, determine the stability of system having the following characteristic equation. So, the characteristic equation in this question is given to us and we need to check that the system given to us is stable or not. So, firstly, we have to perform the formation of the Routh array. After that, we will count the number of sign changes and check whether the system is stable or not. So, to form the Routh array, we will find out the coefficient of even and odd power of s. Here, the even power of s is s to the power 6, s to the power 4, s to the power 2 and s to the power 0. So, these all are the even power of s. So, we firstly write down the coefficients of the even power of s. So, s to the power 6 coefficient is 1, s to the power 4 coefficient is -2, s to the power 2 coefficient is -7, s to the power 0 coefficient is -4. Similarly, the coefficient of odd power of s is s to the power 5 coefficient is 1, s to the power 3 coefficient is -3, s to the power 1 coefficient is -4. Remaining nothing is there, so we simply put 0 here. Let's form the Routh array. So the highest power of s here is s to the power 6. So the Routh array top element will be s to the power 6, then s to the power 5, then s to the power 4, then s to the power 3, then s to the power 2, s to the power 1 and s to the power 0. So our Routh array is ready. Then here the highest power of s is even, that is 6. So we will write the even coefficient first in the Routh array. 1, -2, -7 and -4. Now s to the power 5. So 5 is an odd number, so we will write the odd power of s. So 1, -3, -4 and 0. After that, we will fill all the elements of a Routh array by the cross multiplication method. So, starting with the cross multiplication method, 1 will be multiplied with -2, 1 into -2 minus -3 multiplied with 1. The whole equation will be divided by 1. So we will get 1 as an output. So 1 will be written here. After that, 1 multiplied with -7 minus -4 multiplied with 1. Whole output divided by 1. We will get -3 as output. So -3 as output. After that, this 1 will be multiplied with -4 and 0 multiplied with 1. We will get 0 here and whole equation will be divided with this 1. So we simply get -4 here. So -4 will be written here and we will simply put 0 here. Later on, moving to the further multiplication, 1 multiplied with -3 minus -3 multiplied with 1 whole term will be divided with 1. We will get 0 here. Then 1 multiplied with -4 minus -4 multiplied with 1. Whole equation will be divided with 1. So we will get here also 0. After that, 1 multiplied with 0 minus 0 multiplied with 1 again get 0 as the output. So fill this 0 here and this 0 here, and remaining no entries are there, so we will simply put 0. You all notice that this is all 0 row formed here. So this is all 0 row. Again, to solve this Routh array, we have to make auxiliary equation. The only coefficient which will help in forming the auxiliary equations is these coefficient. So let's form the auxiliary equation, and the highest coefficient, highest power of s in the auxiliary equation will be s to the power 4 only. So let's write the auxiliary equation. A of s equals to 1 s to the power 4 minus 3 s to the power 2 minus 4 s to the power 0 plus nothing is there. So we can rewrite this auxiliary equation as s to the power 4 minus 3 s to the power 2 minus 4. This is our auxiliary equation. Then we are going to differentiate this auxiliary equation, that is d by ds of a of s is equals to 4s cube minus 6s. So this is our new equation which we found after forming the auxiliary equation and differentiating it. Now we will fill the Routh array again. So the Routh array will be s to the power 6, s to the power 5, s to the power 4, s to the power 3, s to the power 2, s to the power 1, and s to the power 0 here. Writing these all values same in this Routh array: 1 minus 2 minus 7 minus 4, 1 minus 3 minus 4 and 0, 1 minus 3 minus 4 and 0. Here s to the power 3 is there, and here also the highest power of s is s to the power 3. So we will write the coefficient of s to the power 3 here. So 4 will be written here and minus 6 will be written here. After that nothing is there, so we will write 0 here. Then we will fill all the entries by the help of cross multiplication. Similarly, so 4 will be multiplied with minus 3, minus 6 will be multiplied with 1, and whole term will be divided by 4. Like that, whole procedure will be same. So I am writing that values directly in the Routh array. 1.5 minus 4, 0, 0 minus 8.33, 0, 0, 0. These values you will get after calculating the elements by the help of cross multiplication method, like this. So here the formation of Routh array is now complete, and we need to check that our system is stable or not. So for checking the stability, we have to first count the number of sign changes. So let's focus on the first row of the Routh array, first column of the Routh array. So 1 is positive, 1 is positive, so no sign change. 1 is positive, 1 is positive, no sign change. 1 is positive, 4 is positive, no sign change. But 4 is positive minus 1.5 is negative, so here one sign change. Minus 1.5 is negative, minus 8.33 is also a negative, no sign change. Minus 8.33 is negative, minus 4 is negative, so no sign change. So total number of sign changes is equals to 1 here. So we can simply say that one root lies in the right hand side of S plane. Only one root lies in right hand side of S plane. Since one root lies in the right hand side of S plane, so we can simply say that our system is unstable. So our system is unstable. Thank you. If you like my videos, then please press the like button and subscribe to my YouTube channel.